All right, this is a review for lesson 2.5, which is how you prove angles are congruent. And basically, it's a review of the vertical angle theorem. So we're going to apply the vertical angle theorem. We've already reviewed all the theorems in your vocabulary packet, and we've already added pictures for them, so now we're going to apply those theorems. All right, don't forget the vertical angle theorem. The shape of the vertical angles are bow ties. So whenever you have two angles that cross, you're looking for the shape of the bow tie. And if you find that bow tie shape, you know that the first bow tie piece is equal to the second bow tie piece. So we're going to apply this theorem with vertical angles. All right, so I notice right away in this example that these two angles form the shape of a bow tie. So this angle right here, 4x minus 101, has to be equal to this angle, 2x plus 3, because they're vertical angles, and vertical angles are congruent, or vertical angles are equal. So you set up the equation and we solve it. We're going to subtract 2x from both sides. 2x minus 101 equals 3. I'm going to add 101 to both sides. 2x equals 104 divided by 2. X equals 52. And the direction said find the value of x. And I did, so we're done with that problem. Okay, our next problem. Let me clear my ink. Okay, my next problem says that we are going to use our diagram, and we have to put in the information into the picture. So we're going to first put in this information. The measure of angle ABS equals 3x plus 6. So I find angle ABS. This angle is 3x plus 6. The second direction says the measure of angle RBC is 5x minus 20. RBC is 5x minus 20. Again, I have the shape of these bow ties. And because I have the shape of the bow ties, these are called vertical angles. Vertical angles are congruent. So I'm going to set the equation that 3x plus 6 is equal to 5x minus 20. I'm going to solve this. So I have minus 3x. 6 equals 2x minus 20. I'm going to add 20. 26 equals 2x, and divided by 2, x equals 13. All right, so now I'm going to fill in my information. Find x, this is 13. Find the measure of angle ABS. ABS, we're going to plug in the value of 13 in there. So 3 times 13 plus 6. 3 times 13 is 39, plus 6 is 45. The measure of angle SBC, we're like SBC. Hey, that wasn't one of our equations. How do you get this angle? Well, don't forget from chapter 1, the angle addition postulate says when you have a straight line, you can add these two angles together to equal 180. We just figured out this angle was 45 degrees. So I know that 45 plus this angle equals 180. To find the angle measure, I subtract it, I get 135 degrees. And we're done. Without using the vertical angle theorem, what theorem could you use to prove the angle ABR and angle SBC are congruent? Well, one of the theorems we talked about earlier was this thing called the congruent supplements theorem. Congruent supplements theorem, which says if two angles are supplementary to the same angle, then the two angles are congruent. The same angle is 45, therefore those two angles are congruent. All right, I hope this was a good review for you guys, and you should be able to do the homework for section 2.5. You have a good night.